Page 347, number 25 and 29, ask us to evaluate the given angles without a calculator. So I've given us an example, one in degrees and one in radians. And this is kind of an introduction to the unit circle, which comes at the end of this section. So I went ahead and I drew it. And what you'll notice is I highlighted the fact that if theta is 120 degrees, and I'm looking at the supplement of that angle, it's 60 degrees. So I'm in one of my special right triangles. So since all special right triangles have the same angle values, in this case 30, 60, 90, their trig values are going to be the same. So you can make the length of the sides anything you'd like, even though it's not specified, because whether the side along the x-axis is 10 or 1, they're still going to have the same trig values because the ratios will be the same since they're similar triangles. So what you can do is, what I've done here is, I've assumed then that the side along the x-axis is across from the 30-degree angle, that length is 1. So because of that, I can make my other relationships that we learned in geometry, that the hypotenuse is double that value, which is 2, and the side across from the 60-degree angle is that 1 times the square root of 3. So then I can easily find the cosine of 120 degrees, which is going to be, now remember this technically is -1 because we're on the negative x-axis. So we're looking for the cosine of 60 degrees. So I'm going to use the opposite over the hypotenuse. So in my little triangle, it's going to be -1 over 2, or -1/2. So that's the answer to number 25. Now number 29, very similar, except if you can see the way I drew my angle in standard position. I started at 0. I'm showing a counterclockwise direction around that, and I go past and the 360 and up to the terminal side of the angle. Now, what I want to note is that 360 degrees is, of course, 2 pi, which in 6 would be 12 pi over 6. So if I take my 13 pi over 6 and subtract off that one trip around the circle, what I find is that I'm left with a pi over 6 angle. And pi over 6 in degrees is 30 degrees. So again, I'm looking at a 30, 60, 90 triangle, only this time the angle with the origin is 30 degrees. And you notice that I made the side across from that equal 1. The hypotenuse is again double that. And of course the side along it would be 1 times the square root of 3. But I didn't write that since it's not necessary for this problem, since I am doing sine. So the sine of 13 pi over 6 is going to be the opposite side, which is 1, over the adjacent side, over the hypotenuse, which is 2. So the sine of 13 pi over 6 is 1/2.